What if the ocean could power entire cities? Every day, trillions of gallons of water rise and fall with the tides, a force so predictable, so immense, that it could be the clean energy breakthrough we've been waiting for. This isn't science fiction, it's happening right now with ocean turbines. Beneath the restless surface of our oceans lies a power source of immense and untapped potential, a rhythmic, predictable energy born from the gravitational pull of the cosmos. From the fierce tidal streams of Scotland's Pentland Firth to the powerful currents in Canada's Bay of Fundy, a new generation of pioneers is looking beneath the waves. They are installing colossal underwater turbines, engineering marvels designed to operate in one of Earth's most challenging environments. Think of them as windmills, but submerged in a medium nearly 800 times denser than air. This incredible density means that even a slow-moving current can generate significant power. A single tidal turbine can produce the same amount of energy as a much larger wind turbine, but with smaller blades and a more compact footprint. As the tide flows in and out, the water pushes against the blades, causing them to rotate. This rotation drives a generator, converting the kinetic energy of the moving water into clean, carbon-free electricity. These machines are built to withstand the corrosive salt water and immense pressures of the deep, silently harvesting the relentless push and pull of the ocean. But the true genius of tidal energy lies not just in its power, but in its predictability. Unlike wind, which can suddenly die down, or solar, which vanishes with the clouds or the setting sun, the tides are governed by the immutable laws of celestial mechanics. Driven by the gravitational dance between the Earth, the Moon and the Sun, the tides rise and fall with clockwork precision. We can predict tidal flows years, even decades in advance down to the minute. This reliability offers something truly revolutionary for our energy grids. A constant, dependable baseline of power, available 24/7. It is a power source as eternal and reliable as the moon that controls it, promising a future of energy stability. But here's the twist. The part of the story often left out of the glossy brochures. While the ocean's power is immense, harnessing it is one of the greatest engineering challenges humanity has ever faced. Building these colossal structures underwater isn't just difficult. It's a battle against the very nature of the sea itself. The ocean is a relentlessly hostile environment. Salt water, a powerful corrosive agent, wages a constant war on any metal submerged within it. It eats away at steel, compromises structural integrity, and demands the use of exotic, incredibly expensive alloys just to survive. And it's not just a chemical assault. The sea unleashes a biological one too. A phenomenon known as biofouling sees marine organisms colonize every available surface, adding immense weight and drag, and slowly strangling the efficiency of the machinery. Then there's the delicate ecological balance. We can't simply drop giant machines into pristine marine habitats without consequence. The spinning blades, no matter how slow, pose a potential risk to curious seals, migrating fish, and even majestic whales. Protecting this life is paramount. It requires years of environmental impact studies, sophisticated monitoring systems, and innovative designs to warn animals away. Every installation becomes a high-stakes negotiation between our energy needs and our responsibility as stewards of the planet. And finally, there is the staggering cost. The logistics are a nightmare. You need specialized, multi-million-dollar vessels to transport and lower these multi-ton behemoths to the seabed. Highly trained teams of commercial divers and ROV pilots must then work in treacherous, fast-moving currents to secure and connect them. Maintenance is even more daunting. A simple repair that would take hours on land becomes a monumental, weeks-long operation at the bottom of the ocean. It's a daunting list of obstacles, enough to make you wonder if it's even worth it. Yet despite these colossal challenges, the world's leading energy experts and engineers are not just hopeful, they are certain. They believe that tapping into just 1/10 of the planet's accessible tidal potential would be a revolutionary leap forward for humanity. That fraction alone could generate enough electricity to power over 120 million homes. That's the equivalent of the entire populations of the UK and Canada combined. And unlike solar or wind, this power source is utterly predictable, as reliable as the moon in the sky. The tides offer a consistent, dependable baseload power that could stabilize our energy grids and wean us off fossil fuels for good. So imagine it. The great coastal cities of the world, New York, London, Tokyo, Shanghai, Their iconic skylines no longer shrouded in smog but glowing brightly, powered by the clean, rhythmic pulse of the ocean. This isn't just about keeping the lights on, it's about forging a new relationship with our planet, where the very heartbeat of the sea fuels the heartbeat of our civilization. In the global quest for clean, reliable power, a new frontier has opened: the immense untapped energy of our oceans. Nations are now in a high-stakes race to master tidal power, a technology that promises predictability and potency far beyond wind or solar. At the forefront is the United Kingdom, leveraging its unique geography of powerful coastal currents. Off the coast of Scotland, the Maygen project, one of the world's largest tidal arrays, is already operational. These underwater giants are a testament to British engineering, converting the relentless push and pull of the tide into clean electricity for thousands of homes, proving the technology at a commercial scale. Not to be outdone, China has entered the race with formidable ambition. Along its extensive coastline, the nation is deploying and testing colossal turbines, some with blades spanning over 20 meters. Driven by an insatiable demand for energy and a national mandate to lead in green technology, China's manufacturing might could dramatically scale up production and drive down costs for the entire industry. The competition is fierce and global. Canada is harnessing the legendary tides of the Bay of Fundy, which has the highest tidal range on Earth. South Korea operates the world's largest tidal power station by capacity, the Siwa Lake Tidal Power Plant, a massive barrage that showcases a different approach to tidal generation. Meanwhile, a wave of innovation is being driven by agile private startups. They are pioneering new designs, from sleek biomimetic blades that mimic the movement of fish to minimize environmental impact, to advanced composite materials that can withstand the crushing pressures and corrosive saltwater for decades. This isn't just an engineering challenge, it's the new geopolitical chessboard. The nations and companies that win this race won't just be powering their cities, they'll be securing energy independence, exporting groundbreaking technology, and writing the next chapter of our planet's energy future. The oceans have truly become the new battleground for renewable energy supremacy. As climate change threatens our future, the answer may lie not above us, but below the waves. Ocean turbines could transform the seas into an infinite source of clean power. The question is, will we harness the tides in time, or will this opportunity drift away with the currents?